Пока мы продолжаем тему блокчейна, и я прошу Николету выйти на сцену к нам.
Раз. Well, I'll go back to English, mostly because I feel a bit more comfortable in this language and I can make more jokes, so that it's way more accessible. So, yeah, blockchain. Anybody is sick of this already? I mean, how many times can you hear a single word and then become just pretty much annoyed and start hating it forever? I know I do, at least to some degree, and I am working with this technology. And currently, no matter where you go, no matter what you read, you will see some kind of information like, let's add blockchain to this, let's add blockchain to that, let's make, I don't know, washing machine with blockchain, let's buy tickets with blockchain. It kind of looks something like this. So you add blockchain to pretty much everything. And there's the people that don't really know about the technology and they kind of look at all this and I don't know what to invest in, I don't know what to do. Then there's the people that create all these projects and they kind of start thinking what next to use the blockchain in. And in the middle, somewhere wedged inside there are the developers that are kind of like, what next are you going to think for us to create? What kind of next weird mind thing you are going to come up with for us to create? And I am a developer. I will show you today the perspective of developing on the blockchain as a person that has been working on it for a bit of time. So you might ask yourselves, naturally, who am I? Well, I am a developer, as I said. And I have been working with a lot of technologies in my life. I started with JS for about a year and a half, and then I went to C#, I went to Java, and I think I kind of maxed out my bingo card of transitions to technologies. And about 10 months ago, I decided to interview at Titanium.Company, at which I currently work, and they asked me, what do you think about blockchain? What do you know about blockchain? And at that point, my answer was, I think that's pretty much hype. I don't know what the hell it is. And isn't it just Bitcoin or something? But no, they asked me, do you want to write code on the blockchain? I had no idea. But still, they took me. And since then, it's been 10 months of working on the blockchain, writing code, finding out that yes, you can write code on the blockchain. And today I'll take you pretty much through all the journey from the start to what I have learned through all this time, what I have come up with, the principles and whatnot. To start talking about coding on the blockchain, I have to specify what it means. I mean, I'm not just writing code in Java or JavaScript or some kind of other language and compiling it and somehow adding it to the blockchain. The thing is that I write specifically for the blockchain Ethereum, and the code written on Ethereum is called smart contracts. To start talking about Ethereum itself, I would have to explain how it is that it can actually execute code. Because Bitcoin, as mentioned, it does not have the code, it's pretty much for transactions between cryptocurrencies. Ethereum is for code execution. And it enables doing that by running a little something called EVM under the hood on every single machine that runs the blockchain. So EVM is Ethereum Virtual Machine. And it can do pretty much any computation. It's a quasi-Turing complete machine, which means that it can actually perform solve any mathematical problem. But the little word quasi before that means that not really. Because just as in this example with a car, it's like setting for it a road and a trajectory for it to go, but if we do not specify how long for it to go, it will go forever and that will violate the laws of physics. So we need somehow to stop any possibility of executing infinite loops or something like that. For that exists the concept of gas. It's everywhere. When you code on the blockchain, on Ethereum, the concept of gas, it seeps into every part of the code that you write. It basically determines how many operations you can execute per function call or per deployment or whatever. If it goes over, then it reverts all the changes and you have pretty much lost money, because gas is money. Gas translates into Ether, which is the cryptocurrency of Ethereum, and that translates into dollars, currently at about $200 per Ether. But the thing about gas is that you can set the price for it. So you basically determine how much your transaction will cost. But it will cost something. And the more operations you make, the more it will cost. So it's better to optimize your code as much as possible. And I say code. What do I mean by that? Well, I mean the code written in Solidity. Solidity is the most popular language currently of writing contracts on Ethereum. And if you look at it, it kind of is similar with something or other. Basically, the creators of it wrote that they're inspired by C++, Python, and JavaScript. And you kind of can see there, like, well, the curly braces are there as well. There are functions, there is the possibility of importing or requiring different files, of having dependencies, of returning values, of having types that are pretty much the same, like Boolean and everything. And it has a lot of similarities. The learning curve of having to write in Solidity is not that steep. You can actually learn pretty fast. The problem begins when you start realizing how much there is the correlation between writing code and realizing how much money you have to spend for it. So there are some concepts that are not in other languages, and or at least not the same, and you have to realize them, to implement them, and always keep them in the back of your mind. So the first one would be the fallback function. It's the possibility that if you send Ether to a contract, to a smart contract, it can execute some code. It can automatically execute some code. Because functions on the blockchain, they do not just call themselves. You have to trigger them. Something from the exterior has to trigger them. And anything can trigger them, pretty much also sending Ether to them. I will talk later about how this was exploited, but this is also one of the things that you have to keep in mind when you write the code. Another thing is for what you pay money and for what you don't pay money. You pay money for anything that changes the state of the blockchain. You pay you pay money for anything that changes the variables on the blockchain, the values of them. If you just read from the blockchain, you don't pay money. So that's pretty much getters and setters. You pay money for setters, you don't pay money for getters. The third one I would say is, it's something that you kind of, when you come to this language, you try to put loops everywhere because, well, you get used to it in other languages, but here there's pretty much only the for loop, and that is to be avoided at all costs, because the more you have, the more loops that you have, the more gas it will cost. And if you do not control how many times it will loop, then it can pretty much very easily go over the gas limit, it will revert, it will fail, your function will fail, and the call will cost money that will not be reimbursed in any way. So always optimize the code and do not use loops. And the third one, probably of many specifics of writing on Solidity, would be that you write events just to be able to debug anything. Or to see what's the end value of variables at the end of a function. Because the difference between transactions and message calls is that when you read something, you pretty much get the result instantaneously. Well, a bit kind of instantaneously, but transactions, they take time. They have to be mined on the blockchain. So you don't know when it will come, when the result will come. So you can just listen to the blockchain, to the events that it will trigger, and this is kind of the way that you can actually realize when your function has been triggered. Okay, so I just described the way that you write contracts. Well, it's basically writing code. But developing on the blockchain is far more than that. You write code, yes, but then starts the magical journey of actually getting all this code on the blockchain. So you use, and we use, the Swiss knife of development on the blockchain, which is Truffle. You have your code, but you have to check, well, how does it behave on the blockchain? How to migrate, to deploy it into the blockchain, how to compile it, and it comes to your rescue. It pretty much allows you to debug, test, migrate, do anything that you want, and it's pretty handy since it's open source. And the first stage of actually testing all of the things that you do is local. So you use another utility, Ganache, and you simulate a blockchain on your local host. And you test a lot, you just write different tests. And let's say that you have come to a point in which you're confident in your code. Well, that's not all. You have to get it to the blockchain. How do you get it to the blockchain? Well, you have to use the utility called get to raise a node of the blockchain locally, and through it to send the code to the blockchain. Or you can use a node that is set up by a company. Well, the most popular one is Iliuha. They have open nodes for a lot of kinds of blockchains that you can just connect to and send code to. The problem here is that if something happens to these nodes, it kind of breaks everything for you. So it's better to raise your own nodes, but the downside of that is that it will cost a lot of gigabytes of memory. Okay, we have gotten our code, we have tested it, we've got it to the blockchain, and there is one step left, is connected to that code. Because, well, you have code on the blockchain, and what? I mean, it sits there. You have to trigger its functions, you have to get data from it, it has to do something, right? And you do that with the help of different libraries. There is the Web3 library, written in actually a lot of languages, but the most popular one is for JS. You use wallet applications like MetaMask, Ethereum wallet, and through all of that, and that's a lot of writing of JS code, and for mobile applications, well, Java or Swift or whatever code. And at that point, you have created a blockchain ecosystem. It comes from the contracts and finishes at the connection to the contracts on the browser or mobile application. So you can see that it's not just writing Solidity code. We have to be kind of jack of all trades. And I can speak from my personal experience. As I said, I've worked 10 months already with these contracts, and I remember the first task that I had was to create a proof of concept, which was basically a token, like kind of cryptocurrency. Something that can be traded, something that can be bought, something that can be sent to someone. And I was so proud of myself for having read the documentation of Solidity and having written code that kind of looked like this. It was a lot of code. And no, it did everything that it had to do, and I was very proud of it, because at the first time I wrote code on the blockchain. But then my team lead kind of came, looked over that and said, you know what, you can use OpenZeppelin and reduce that to 5 lines of code. You can just import a class, well, another contract, and let it do anything for you. And at that point I realized the importance of reusability. So I did not have to write contracts by myself. I actually could use contracts written by somebody else, and that was in the crowd sale, so an ICO, as was mentioned. And for that I had to write code from the start, I had to write a lot of specifics, and then came something new, something that I had not done, and that was deploying to the main blockchain, to mainnet, Ethereum blockchain. You know, that is very dramatic. Anytime you deploy something on the main blockchain, some kind of dramatic music must start and some fire must shoot out, because it's very, very scary to do that. You're using the money of your client, and you're trying, desperately hoping that you did not make any kind of mistake. Because one thing about the code on the blockchain, you cannot patch it. You cannot just, okay, I did a mistake, and okay, 2 months later I'm going to patch it, I'm going to roll a new update, and that's that. No, if you made a mistake, first of all, there's a possibility that all the money that you accumulated there will be lost in some way if it can be exploited, or there's a possibility that, well, anything else can happen, and you have to write new contracts, you have to deploy new contracts to create correlation, and that's a lot of headache. So you must make really, really sure that your code is secure. So when I was deploying in the mainnet, my colleagues were very helpful. They created a very helpful atmosphere of singing Armeno to me while I was deploying these contracts, and it was a very nice atmosphere, I have to say. I was very scared, and the moment I stopped being scared about that was when the whole ICO ended, and that was about 2 months later. So 2 months I was pretty much waking up in the middle of the night and thinking, oh my god, I made a mistake in the contract. It's going to fail at some point. And it's going to fail, and I was thinking, okay, how many years will I need with my salary to repay the money gathered in the contracts? So it's pretty scary. And it went from there, like I wrote some other contracts, and the project I'm currently working on, it's the biggest project I have worked on since I started working on a blockchain, and it's something that needs a private blockchain. So how it went, it was pretty much, okay, we have this kind of project, here is the technical research, you have to make a private blockchain, go. And you kind of go, how do I do that? Well, it's not that hard, but it was an experience. It was interesting to implement. So created, it's not that hard really. Created my own blockchain with the mining time of 5 seconds, with proof of authorities, well, a lot of custom things, and connection to the public, and it's honestly a thing of beauty what was created. A lot of interconnecting modules, and what that taught me is that there's infinite space of growing. There's always going to be the next project that's going to test your limits, that's going to make you think, I cannot do it, I've never done that before. And after about 5 months, when to do this project, you're going to be, it's working, I did it. So after, as I said, 10 months, kind of after auditing, after writing contracts, I kind of come to the conclusion that there's the same principles to writing the contracts all the time. Generic principles, to be honest. And because everybody loves acronyms and everybody loves pretty interesting acronyms, I decided to condense this into the acronym of SMART. So let's see what every letter of this acronym means in writing contracts on the blockchain. So S is for simplify. You do not have to pay for the operations that you do not use. You have to simplify your code to the point of it being insane. You do not use and you do not declare variables that you do not need to be declared. You do not use win 256 for holding int value that will go only to 10. So you have to always think about optimizing. You don't use arrays to the point of infinity. You don't create something that will use a lot of money, so simplifying is key. And you learn that when you write a contract and you're very proud of it, and then you realize that you cannot deploy it on the blockchain because it weighs about 8 million gas and the block limit is about 7 million. So that's kind of sad at that moment, and you have to simplify and optimize it to the point that it looks like a skeleton, but it is pretty. It's a pretty skeleton of a code. The second is M for maintenance. Well, maintenance, I don't think I have to tell developers that you have to write code that can be read by other developers. Because, well, you write code for other developers, for other people, not for the computer, really. But in smart contracts, it's doubly important that. So, first of all, you should be able to realize what you've written about 1 month after. The other people should be able to realize what you've written 1 month after. And after about a year or 2 years or 3 years in development and smart contracts, you have to be able to go back and realize what's going on there. So it has to be written with the mindset of not 1 month, not 3 months, but years and years and years of time. Because these contracts are going to sit on the blockchain and be used sometimes for years and years. And you have to look and think ahead for that. If you want to add the functionality of burning tokens, you have to add it at the beginning. You don't think like, well, at some point I will do that. It doesn't work like that. So do not write bad code and think that you can patch it later. Write good code right away. A is for audit. Well, auditing is an interesting concept added in the blockchain that you have to get other people to look at your code. And it's not like you want to do it or whatever, you have to do it. Because you might make mistakes that you cannot see right away. And there are two alternatives. You can either use an audit company that's going to take thousands of your dollars and will provide you a report about the safety of your contracts and the way it can be exploited. Or you can just ask a colleague to look over at your code and do a code review and tell you where you pretty much did not do a very good job. But you have to do that. Deploying contracts without a code review or an audit is quite irresponsible. And the next point would be R for reusing, as the way I reuse the meme. And as I said, my first proof of concept project, I learned that I have to reuse contracts written by other people. And these contracts, they're not limited for just proof of concept projects. We use them everywhere. The Open Zeppelin library of open contracts that can be used by everyone, it is used by everyone. And these are audited, tested, retested, re-audited contracts that you can be very sure they have good quality. So it is paramount to using code that you know that it works. Not experimenting at the last minute and then deciding that I'm going to push it and maybe it will work. And the last point would be testing. You have to test. And as opposed to web development or maybe mobile development where testing is kind of an afterthought sometimes and you think that, well, I'm going to write this code and then maybe if I have some time, if the client allows me, I will write some tests. In smart contract development, testing is part of the development. So testing is mandatory. You have to write these tests. Because otherwise, you are sending unverified code to the blockchain. And who knows how that's going to explode into your face. And speaking of exploding in your face, I will say what happens when someone doesn't check their code. There have been some hacks on the blockchain. To clarify, that means that something happened with the code on the blockchain, not the blockchain itself. And people lost a lot of money. So, from the point of the developer, let's just analyze the 3 biggest hacks on the blockchain. And the first one, the most widely used one, is the DAO hack. I think maybe people who are not on the blockchain, maybe they even heard about the DAO hack because it was pretty monumentary. So, what was the DAO? The DAO was basically a contract that allowed you to invest in various projects and also gave you the possibility of getting your Ether back from it. And here is where the problem lay. The problem was in 2 lines of code. So, the line of updating the balance of a user after they actually do some kind of transaction, and the line that does the transaction. So, what do you think? What should be the order of these lines? So, should the contract first update the balance and then transfer the funds? Or should it transfer the funds first and then update the balance? So, which variant is the optimal one? Sorry?
Transfer before.
Transfer, then update.
Yeah.
Okay. You see, the problem is, they thought the same. They thought the same and their code worked like that. They transferred the funds and then it updated. Except they forgot about the little thing called the fallback function that executes code automatically when you send Ether to it. So, look at how the hacker worked. So they ask the contract, give me some Ether back. And the Ether is being sent not to their account address, but to a contract that belongs to them. Since Ether is coming to the contract, it triggers the fallback function. The fallback function can execute pretty much anything. And guess what? It calls back the function and asks, give me please back, give me some Ether as well. But the thing is, because the transaction happens before the updating, it's all in one thread, I should say. The balance has not been updated yet. And basically what the contract sees is that there have been no transactions. And okay, he sends the Ether again, which again triggers the fallback function. Again, they call the function, the fallback function calls the function for transferring Ether, and it goes on forever. That pretty much is a loop of sending Ether to the contract of the hacker. Well, 3.6 million Ether to be exact. At that point, that was a very big percentage of all the Ether that existed in the entire Ethereum ecosystem. So at that point, it cost about $80 million. And it was pretty tragic. So imagine seeing pretty much all your investments at that point going to some kind of bad person. But the point is that at that moment, this Ether was not in their account. It was locked for 30 days. So the developers of Ethereum, they got together and they started thinking, well, what should we do? On the blockchain, it's kind of, there's the principle, what happens on the blockchain stays on the blockchain. But this case was, well, out of the ordinary. A lot of people lost their money, and it was because of a little problem in the code. Well, shouldn't they be able to change, to revert something, to help people? Because, well, it was nobody's fault except the developers. But, well, what can they do? So, it split into two groups of people. The group of people that eventually did that, they created the fork, they changed the code so that nothing happened. And the group of people that thought that what happens on the blockchain stays on the blockchain, and they became Ethereum Classic. So this is what happens when you do not check your code. Your entire community splits into two pieces, and they kind of always argue with each other. And what came out of it is a very important pattern in writing smart contracts code, the checks, effects, interactions pattern. So first, you have to check, for example, the balance. Second is the effects. You have to update the balance, and then the interactions. You have to send them to interact with some other exterior contract. Well, that wasn't the only hack. So parity is a kind of wallet, a way for people to hold their cryptocurrency and whatnot. And they have a little problem. The problem is that each contract had the possibility of being reinitialized. They had a little function of initializing the contract. And normally it can be called only once at the beginning by the owners, and it is set normally. But the problem is that when data was sent to a function of a wallet, it checked if there is a function with the same name to execute. So let me walk you through that. Someone sends the init wallet data, let's say, and the wallet executes that function of initializing, bypassing all the ownership checking. But what people did is just they got themselves ownership of the contracts, and they got all the Ether out of it. So, to the tune of 150,000 Ether, at that point, $30 million. And the parity went, well, my bad, we're going to fix it, got it to a separate library. And that brings us to the third hack that also happened on the parity as a result of this fix. Well, here's a question for you. For example, you look into the code of a utility that you're using. And you see that there is the possibility to destroy this function, to destroy the code, and to effectively freeze all the assets that depend on this code. Would you do that? Well, who would do that? Raise your hands. Yes. Okay. The thing is that somebody did that. So it pretty much started with a post on Reddit in which someone wrote, "My bad, I killed the parity wallet." And they honestly, they discovered that the code, the generic library code that was used in every contract, it was a wallet that was not initialized. So they initialized it, and they saw that, hey, it has a kill function. Let me call the kill function. And they destroyed the contract. Every single wallet that depended on this functionality was frozen, with no possibility to get any kind of cryptocurrency out of it. They lost 500,000 Ether and other currencies. It's not lost, it's just frozen and inaccessible. Well, you can call that lost. And at that point, they really don't know what to do with it. Some people started again proposing a fork, like that's the only solution for fixing bad code problems. Oh my bad, we have to change the whole ecosystem again. But that really teaches you how bad it can get if you just make a little mistake in your code. So that's why we test, retest, re-audit, audit again. And we do not sleep nights, and we wake up all the time thinking that, oh my god, I'm going to make a mistake and everybody is going to lose their money. So I guess the question would be why? Why am I coding on the blockchain? Why am I writing code for a system that is so error-prone and so easy to lose money on it? Well, it teaches you to write good code. It actually makes you write good code. You have to optimize everything. You have to write it in a way that it will cost you less and less money. And it's not an option. It's not a thing of, I'm going to write this code now and then I'm going to optimize it. You have to write it right now. You have to write good code. You have to educate yourself to write good code. And that is something that you have to educate yourself to write tests all the time. So basically it teaches you to be a better developer. And you always learn new things because the ecosystem is very new. Ethereum appeared in what, 2015, so that's not that much time for people to actually get used to writing code on it. And it's interesting to see how it evolves because the Ethereum 2.0 is coming and has the changes like sharding and plasma and state channels and everything that is going to pretty much change the way that we write the code. It's interesting to be a part of it. It's interesting to see how it evolves and how you can get better with it. And even though locally we don't have that many people who write on the blockchain or who are interested in the blockchain, unfortunately, but we are trying to get people interested. We have created the Blockchain Developers Moldova community on Facebook, which you can join if you want. We post their information, articles, we had a workshop as well. And it's not because blockchain is a hype technology, it's because it's an interesting technology. It is hype right now, but like the dot-com bubble, it's going to go away. The hype is going to go away. And when all of this washes up over everybody, what we're left is the question, where is it needed? Where can we use it? And how and who is going to write the code for us? And we as the blockchain developers are going to be there to help everybody write the code that they need. Thank you for your attention. If you have questions, ask them. So, questions in English, Romanian, Russian? Maybe turn on the light because I really cannot see anybody down for
Nicoleta,
Hi.
Thank you very much for your presentation. It was really interesting to see it from a perspective of a developer with code snippets. And you know, as a developer, I always have discussions and I'm an advocate of best practices and principles like solid design principles, test-driven development and so on. You've mentioned something about testing, and you mentioned about testing, writing tests. It was not clear whether there are possibilities to do some manual testing, automated testing, or even write unit tests for documents.
Well, the testing on a blockchain is written, we can write it two ways. You can either write tests in Solidity, but that's not really done. Mostly we write tests in JS. We use the Mocha and Chai libraries to write the tests. And it's pretty much testing all kinds of scenarios. So we test any kind of interaction with the blockchain, any kind of interaction with the code, and the extension of testing is pretty much the extension of the scenarios that we test. We sometimes can have thousands of lines of code of written tests just to be able to test just a single contract, because we have to do that. I hope that answered your question. Okay, any other questions? Okay, there's one.
Salut!
Bună! Da.
Prezentare foarte faină, mersi mult.
Scuze, nu se aude bine.
Vorbesc mai tare.
Da, acum ok.
Prezentare faină, mersi mult. Mă interesează, sunt aplicabile pattern-uri gen Grasp, Go și Solid în codul scris în Solidity?
Well, ca Solid, nu știu dacă aș numi asta ca pattern, mai mult ca un fel de guidance, cum scrii cod. Dar ideea e că, ok, ca single responsibility, firește că, cam, ok, zicem așa, nu, single responsibility probabil nu chiar, deoarece majoritatea contractelor noi le scriem mai multe funcții într-unul, pentru ca să nu coste deployment-ul așa de mult. Așa că des ne găsim în așa niște situații, cam tot codul se află într-un singur contract, care poate fi considerat ca un singur clas. Așa că noi de obicei separăm contractele atunci când este nevoie de că noi nu putem deploy un singur contract deodată și noi îl separăm în mai multe bucăți pentru a face posibil în general băgarea codului acesta pe blockchain. Noi, din acest punct de vedere, v-aș spune că noi separăm codul atât de puțin cât în mod normal se separă, zicem, după Solid, după Single Responsibility. Pattern-urile, dacă cinstit, eu probabil nu-mi dau chiar așa de tare seama de fiecare dată când scriu cod ce pattern-uri eu folosesc, dar cel mai important pattern e probabil simplify, adică cât mai simplu scris posibil. Aceasta e cel mai important, cât mai puțin asta se coste. Deja, dacă se dorește de implementat un pattern care va crea posibilitatea de a scrie mai mult cod pentru a implementa acest pattern, asta nu va fi optimal. Pur și simplu de aceea ca să va costa foarte mult pentru va fi scris după pattern, dar va costa foarte mult. Din contul acesta nu prea are sens de implementat toate pattern-urile care au overhead de cod. În acest punct de vedere, eu probabil nu pot spun concret care pattern-uri putem să-l folosim, dar pot să spun că cel mai important în cum ai scrie și care pattern nu ai folosi, e să scrii cât mai simplu și cât mai puțin. Așa, pentru întrebare? Cineva mai are întrebări? Any questions? Iată.
В чем фишка? Есть поддержка IDE, блокнот, Win.
Я пишу на Visual Studio Code. Но вообще есть поддержка, конечно, для тех же там IntelliJ, все есть поддержка Solidity, самого есть линтеры для Solidity. И, в принципе, вот это единственное, что нужно. Есть SolC, как extension, который позволяет видеть не только столь проблемы в том, как написан код, сколько проблемы в функционале этого кода. Например, где-то забыли прописать то есть детали о том, кто может вызвать эту функцию, или одно, другое, третье, десятое, и он именно с точки зрения функционала будет это выявлять. Есть еще линтеры, которые с точки зрения того, как написан код, будут выявлять. Но то есть мои коллеги пишут и на Visual Studio Code, и на продуктах IntelliJ, и в основном я заметила, что саппорт хороший и для одного, и для другого, для тузов, для development Solidity. Но вообще можно писать, конечно, в Notepad, как и все, в принципе.
Еще вопросы? Тогда, Николета, спасибо.
Спасибо. Что, ты рамочки, что ли? Я чувствую рамочку.
Обязательно. Розовая рамочка.
Я как раз хотела посмотреть дыру у меня в стене.
Хорошо, давай. Смотри, если хочешь, если как-то сделать, я Николета, как без меня захочешь на стену повесить. Спасибо, спасибо, Николета, огромное, спасибо. Спасибо.